Hello, learners. My name is Tembele Matoti. I am from St. John's College in Umtata, but I come to you more today as the Deputy Chief Marker in the NSC exams. Welcome to the Eastern Cape Department of Education broadcast studios. Today's lesson is about drainage patterns. I'll be covering this topic for your full understanding. Most importantly, this topic falls under geomorphology. So you should be able to understand that it is physical geography. Let us get started. First of all, you need to understand that we need to talk about stream patterns. And what are stream patterns by definition? The stream patterns are patterns that are identifiable on the surface of the earth. This is something that you would be able to see on a topographic map. This is something that we'll be able to see on an orthophoto map. This should be something that we can be able to see if it is drawn on a particular frame for your own identification. So most importantly, it must be on the surface and it must be something that you can see. It's not something happening underground. It is on the surface, something visible and identifiable. So what are the major drainage patterns that the examiner is looking for when he is looking for content? Here is a diagram that I'm bringing to you that is a collection of drainage patterns, of stream patterns that you can see. First and foremost, there is one that is here. It is completely separate from one that is here and completely separate from one that is here, and the last one is there. So if you look at this figure, you must be able to clearly separate all four and be able to identify them. Now let's see. The first one and the most common one is the dendritic pattern. The word dendritic is taken from dendra, which is a Latin word, which means shaped like a tree. So by definition, this is shaped like tree branches. And this happens over rocks of uniform resistance. Now, how do you define what you see? Here we have got tributaries that are joining each other at acute angles, meaning angles smaller than 90 degrees. And the tributaries themselves also join the main stream at angles that are smaller than 90 degrees. For mathematicians, that would be called an acute angle. Let's hold it here for now and see if you can identify my approach already. What I did was to identify the drawing and say it is a dendritic pattern, meaning you must be able to look at the drawing and be able to say, this is what I see. Or alternatively, the examiner will ask you to draw a particular pattern, meaning you must, number one, be able to identify or draw. Number two, be able to describe what you see. I said this is shaped like branches of a tree. Taking that from dendra, meaning dendritic, dendra, shaped like a tree. And then I identified the geology and said it is going to form in areas where the rocks have got uniform resistance. Learners often rush to say they form over igneous rocks. And that is going to be wrong in the exam because an igneous rock is an example. It is not telling us a description of the underlying geology. And then we take the next one, the trellis pattern. Yes, other learners prefer to put an ed at the end, thereby calling it trellis dip. Okay? There's nothing wrong with that. It's all acceptable in the exam. Okay. What do you see in the trellised pattern? You see streams that are flowing parallel to each other, but they've got short tributaries. Okay? Streams flowing parallel to each other with short tributaries. Those tributaries are so short that they don't have to form tributaries of their own as well, because they are short and they are flowing down a steep slope and they quickly join the main stream. Let us see what we see in terms of underlying geology. There are alternative hard and soft rocks. Okay? Remember, the main stream will always flow at the bottom of the valley. So that'll be the softer part of the rock. And the tributaries will come down all the way from the valley into the main stream, meaning they'll be the flowing from the harder part, which is high lying, and down to the softer part, which is low lying. Okay, so the streams are parallel, and the tributaries are short, and they come down the valley to the bottom of the valley. Also remember, alternative hard and soft rocks will also form in areas where there are folds. There are folds. Now let's go back to grade 10 a little bit, where we dealt with endogenic forces and we dealt with fold structures, where we had the open fold, the closed fold, the overfold, and the overthrust fold. So we're building on that and saying you will find the trellised pattern in folded structures. Okay. Now we move to the next one, the radial pattern, which is the one that we see there, the radial pattern. Okay. Radial, English, what does that mean? Radiating outwards from the center. Radial, radiating outwards from the center. But something needs to be highlighted here. Okay. They move from a central point and they radiate outwards. Now, how do we know from this one picture that there is a central point that is raised? There we go. That is a spot height. Spot heights will always be placed in areas that are elevated. Okay, so on a map, you see an elevated area through a spot height, and there'll obviously be a reading of the height in that area. Okay, so clearly here, that's an elevated area. There's a tributary, there's another one. They join together, and that flows outwards. This one here flows outwards. Same applies here, flowing outwards. Okay, so clearly the area at the center, that is here, is higher, and streams go down in terms of altitude. Water never goes up the mountain, it goes down the mountain. Okay, so here, that elevated central point can be exemplified by a mountain, can be exemplified by a hill, can be exemplified by a butte. And also we accept examples like a volcanic crater, because it will be high up there, there's an eruption, and then at the center, there's a possibility that water can come out and then drip down the mountain. So coming from an elevated point, further down, okay? And then here we have got the rectangular pattern, okay? Here we see something different from the others, okay? That the tributaries meander, look at that. They meander. Then you get an angle there of about 90 degrees. That is the right angle. And also the stream itself, the main stream, meanders at bends that are almost 90 degrees. Let's see what we can see on our screen. Look at that. Main stream, there's the meander. Okay? Tributary, there's the meander, almost 90 degrees. So how do we define or describe what we see? We're saying the tributaries meander at 90 degrees. And then we can also say the tributaries join the main stream at 90 degrees. Now, if you keep track of that, then you will know that the key characteristic here is bending or meandering at almost 90 degrees. Yes, in reality, you cannot take a protractor and get the angle 100% accurate at 90 degrees. That's why we're saying at approximately 90 degrees. Now, what is the underlying geology here? The underlying geology is a jointed landscape, or you can say a fault plane, or you can say the rectangular pattern is common along the faults or along the joints. Common mistake, learners. What you normally do in the exam, you write they occur along cracks. And then we mark that wrong. We don't accept cracks. We accept joints, or we accept a faulted landscape or a fault plane, to put it that way. Okay? Now, let's recap what you must know, factoring in my approach. Okay? You must know what it looks like. Whatever drainage or stream pattern you are given, you must know how it looks so that we are able to describe it. Or if the examiner asks you to draw, you must be able to draw it. So, two ways: either you identify what you are given, or you are asked to draw it. Okay. Number two, you must be able to describe what you see. I'm not looking for a genius here. I'm looking for someone who can look at the pattern and describe what he sees. For example, we are going to be saying with the dendritic pattern, it is shaped like a tree, or it is shaped like branches of a tree. So you are able to describe what you see. Okay. And then you must also be able to give me characteristics. Okay. What do I mean by that? Let's take the dendritic pattern and say, beyond it looking like a tree, what kind of characteristic can you say? And I mentioned that the tributaries join each other, or if you are a wise student, you can say the confluence is at an angle less than 90 degrees, or at small angles, or for the mathematically tuned ones, at angles that are acute, meaning less than 90 degrees. You are describing what you see and also giving a characteristic. Okay. And then you go to the geology. We are here now. The underlying geology. For example, we said the dendritic pattern is found in areas where the underlying rocks are those of uniform resistance. And we're able to give an example and say those are your sedimentary rocks, or we also said those are your igneous rocks. Igneous, formed from fire, very hard rocks, uniform resistance. The trick at the end of the day is to be able to integrate all these patterns that you see with map skills. Because this question may be asked straightforward under the geomorphology section, or it may be asked as map skills applicable to the geomorphology section. That is a topic for another day. We'll see how to handle that one. Let us move on a little bit. Okay. Now we're going to take one question paper. I'll try to get a very simple one so that we don't find difficulties as we start out the lesson. Okay. The instruction is pretty simple. Study the drainage patterns in figure 1.2, which is the three of them at the bottom, and indicate to which drainage pattern each of the following descriptions refers. So we are taking the description, or we are taking how you see it and aligning it with the description. Okay. You look at the pattern and then you align with the description. So we are going to be writing only the answer next to the number, assuming you were in the exam. Okay. So let's take 1, 2, 1. Common language 1.2.1, but we'll move faster and just say 1, 2, 1. Okay. Resembles branches of a tree. Okay. Remember what he said? Branches of a tree, Latin dendra, dendritic. So that one there is dendritic. 1, 2, 1, dendritic. Resembles the branches of a tree. Okay. Let's take 1, 2, 2. Forms on rocks that have got many joints and faults. Okay. Remember I said many joints, faulted landscape, fault plane, okay? And there we have the rectangular pattern. Remember the angles, plus minus 90 degrees, bend on the tributary, and the tributary joining the mainstream, and the mainstream bending as well. Now you can see many bends here. Look at that. And look at the tributaries. Look at the tributaries. So those angles are very clearly articulated there. Okay? 1, 2, 3. The mainstream has many 90-degree angles along its course. Giveaway. You can see the red marks here. 90-degree turn. Okay? 90-degree turn. Look at that. 90-degree turn. So again, rectangular pattern. Okay? Let's take the next one. 1, 3, 4. This pattern forms on rocks that have got a uniform resistance to erosion. We even made an example, you remember? We said igneous rocks are an example of rocks that have got uniform resistance, okay? And what was that? The dendritic, dendra, shaped like branches of a tree, dendritic, dendra. Easy, isn't it? My dear learners, these marks are very easy to pick up. So please keep it simple. Just identify the definition and identify the pattern. Then you are good to go. Let's take the next one. 1, 3, 5. Streams flow away. Look at my hands. From somewhere in the center, they flow away. Okay? Streams flow away from a central point. Remember, in our previous image, our previous frame, we even had a spot height there at the center. And I said the spot height signifies a high-lying area, and the streams flow away. They flow away from a central point. What did we say initially? They radiate, meaning they flow from a central point and they move outwards. Okay? So that high point there, we even said it can be a hill, can be a mountain, can be a butte, or it can be a volcanic crater. Clearly, that is a radial pattern. Good to go. Good to go. So far, so good. Let's look at 1, 3, 6 now. The tributaries join the mainstream at acute angles, small angles, angles less than 90 degrees. There we go. Dendra, dendritic. So you can see now this is a collection of questions because I'm trying to get you drilled and practiced up for the exam. It was 1.2 and then we started off with 1.3 so that we are able to get enough practice, enough exercise on how this can be asked from you. Okay, let's look at the next one. 1, 3, 7. Okay, only forms on massive igneous rocks. Obviously, the examiner there wanted to stress a certain point of only forms on massive igneous rocks. But we know there are other rocks of uniform resistance. Okay, now look at that. Massive igneous rocks. Those are rocks of uniform resistance, and that is the dendritic pattern, dendra. Okay, and then the tributaries again join the mainstream at 90 degrees. Remember, this one here looks very much like that one. So that one was tackled, and that is a rectangular pattern. We now continue to the next question paper, which should be more familiar with you learners because it was written a year or so ago. And this one here has got only two figures. Figure A, aptly referred to as drainage pattern A and B below. Now, before you go to questions, please have a thorough look at the figure, analyze it, and make sure you understand what is happening before you take on the questions. Take control of the figure, own the figure. Don't be dictated to by the questions, because the questions will point you at something and you go look for it while you are not familiar with the whole figure. So step number one, make sure you analyze the figure and you get it right, okay? Now let's look at figure A. Figure A even has arrows that are pointing outwards. Can you see that? Pointing outwards, okay? So remember, we dealt with this one before, and we said they radiate from the center, okay? So that's a radial pattern, okay? And then figure B, you've got parallel streams that have got short tributaries. And you may remember we referred to those as the trellis pattern. We even said some learners actually add an ED and have a trellised pattern. So let's see what the question looks like, okay? 231, identify drainage pattern A. We're good to go. That is a radial pattern. I will attach the marking guideline so that you see what we're looking for and how we mark, okay? Look at that. We are accepting a centrifugal pattern, but we don't recommend that you use centrifugal because most learners will also confuse that and write centripetal, which is obviously going to be wrong. So radial is what we're looking for because the streams radiate from the center outwards, okay? Then we'll skip 232 because we're not dealing with stream order today and we have got to manage the studio time, okay? Now, 233, give a reason for the direction in which streams flow in drainage pattern A. And we have dealt with that one before. That's why I'm giving you the marking guideline ahead, okay? They radiate or they flow outwards from a high-lying central point. Remember that image that we gave you had a spot height, but we also said you can have another example that is a mountain, a hill, or a butte, or even a volcanic crater. Okay? Now, let's look at 234, which is this one here. How does the joining of the tributaries to the mainstream differ in patterns A and B? Exam approach. Exam approach. Before we deal with the content, what is this question looking for? Number one, it looks for a difference between two things, okay? So in the strict test of terms, if you give me one answer focusing on A and you don't give me B, I'm not supposed to be giving marks because you have not demonstrated the difference. So in this case, analyze the question carefully and focus on the differences and give both A and B, okay? So at A, we have said that here there will be at right angles in B, and at A, there'll be acute. Look at that, acute, okay? Which is small angles, less than 90 degrees. You can see the tributaries. You are describing what you see, okay? You are describing what you see. Here, the tributaries join at almost 90 degrees. That is right angles, okay? But here, look at that one and look at that one. That is an acute angle, small angle, or less than 90 degrees. Key thing, give me both and show me the difference, okay? And then 235, okay? State two conditions associated with the underlying rock, underlying geology. That's what we called it in our first frame, that contributed to the formation of the trellis pattern in drainage B, okay? Alternate layers of hard and soft rocks. We even said, go back to grade 10 and look at folded structures. Your open fold, your closed fold, your overfold, and your overthrust fold. So those are folded rocks. Remember the mark allocation. We'll give you 2 marks here and 2 marks here. That totals 4 marks. That totals 4 marks, okay? Now, we move to the last question, which is an application question, okay? We want to understand that you have known the theory, you've got the concepts, but how do you now apply the theory into real life situations, okay? Why are human activities, meaning what people can do, why are they limited in areas with drainage A and drainage B, okay? Remember, in A, we are talking about a hill, a mountain, a butte, or a volcanic crater. So the slopes on the side are clearly very steep and uneven, okay? Steep and uneven. The same applies to folded structures, which is at B. You get one high-lying area that is hard, low-lying area that is soft. So the area itself is undulating, it is steep, and therefore not suitable for human activities. Okay, so the steep and uneven, that will give you 2 marks. Okay, either. Okay, if you write both, you can only take one. Okay, now because the area has got steep slopes, it is prone to soil erosion, and the soils are very worn, they're very, very thin. So there's not much you can do there in terms of agriculture. Okay, and therefore the soils are very, very infertile because they are worn. Okay, they are eroded. Every time you get rainfall, it washes down the rich topsoil, the nutrients are gone. Okay, and also remember, with heavy precipitation and the slopes, there's bound to be a very strong force of gravity, and therefore triggering mass movements, your landslides, your soil creeps, and all those things. So it's not going to be conducive for human activities. Okay, and also because the land itself is mountainous, it is hilly, it is folded, it will be very, very expensive to develop. Okay, so there might be other answers that learners have, but we try to align those answers with what we have in our marking guideline. And we want any two of those, meaning 2 marks, 2 marks, and we give you 4 marks. Okay, dear learners, we have come to the end of our lesson. You can leave your questions on the comments box or queries, but don't forget to leave the name of your school so we can give shout outs. And please share, recommend, and subscribe to our YouTube channel. It's ECDOE Broadcast Studio. Thank you for watching. See you on our next lesson. Remember, the warmer the blankets, the colder the future. Wake up, study hard. This is your last chance after 12 good years, and make good of it. Thank you, and good luck for your exams.